Alright, so these notes cover multiplying binomials, okay? And we're going to talk about a couple of different ways that we can multiply things that end up looking like this. We might have, oh, that didn't work. We might have like an x plus 4 times an x minus 3, okay? How would we multiply these things together? Okay, so we're just going to go through a bunch of examples, some notes on how to actually do these things, and I'm going to show you two different ways. All right, first things first, how do we multiply these binomials? The first thing that we do is we distribute. Okay, each term in the first set of parentheses to each term in the second set of parentheses. Okay, so everything that's in the first pair of parentheses, we're going to multiply it into the second set of parentheses. A thing to remember is that when we multiply exponential expressions, we have to add the exponents, okay? Sorry, it looked really bad, so I'm just gonna, there we go. We add exponents, okay? And then we simplify. Okay, and when we simplify, that usually looks like combining like terms, which are the middle two terms, 9 times out of 10, the middle two terms. So multiplying binomials, we distribute everything to everything in the first set of parentheses to everything in the second set of parentheses. We add the exponents, and then we combine like terms of the middle two terms, okay? So what exactly does that look like? If you look down here, this is what it looks like, okay? So we take everything in the first set of parentheses and we multiply it, we distribute it to everything in the second set of parentheses. So if I were to zoom in on this, we take A times C, so A times C, plus A times D, plus B times C, plus B times D. Okay? What exactly does that look like? Everything in the first set is distributed to everything in the second set. So we're going to start, I'm going to do the first one with red, okay? So we're going to take x times x, okay? Now that's x1 times x1. Because they're the same base, we add the exponents, and 1 plus 1 gives me 2. So just as a reminder, x times x is going to give me x squared because they have exponents of 1. So when I multiply that, I get x squared plus x, oh hey, it's moving, plus x times 5, which is 5x. Okay, switch up the colors a little bit. Now we're going to go with the 2. All right, we're going to take 2 times x plus 2x, and then 2 times 5, which is 10. The next step is to combine like terms. The only two terms that we have that are like terms are the 5x and the 2x. So my final answer, x squared plus 7x plus 10. Okay, so that's multiplying binomials. Okay, one of the ways that we call that, or one of the things we call that is actually foiling. Okay, so first, multiply the first terms together, so that's x times x. Okay, outside, where we multiply the outer terms together, so that would be x times 5, because those are on the outsides of the parentheses. Inside, multiply the inner terms, so that would be 2 and x. And then L represents last, so that's 2 and 5. Okay, that's exactly what we just did on the slide before. Okay? Write the terms of one set of parentheses across the top and write the terms of the other set of parentheses down the left side. Multiply each row by each column, add diagonally. Okay, so the first thing we did was distributing, like double distribute, FOIL method. This one is the box method, and to be honest, sometimes I like this one a little bit more, simply because it looks more like a multiplication table. So each one of these parentheses has 2 terms in it. So I know I'm going to have a box. Let's move it over a little bit. That has a row of 2 and a column of 2. So I'm going to take this first one, x plus 2, and I'm going to put it on the top, x plus 2. I'm going to take the second one, x plus 5, and I'm going to put it over here, x plus 5. Okay, so now it says in the directions, multiply each row by each column. So x times x gives me x squared. Oops. X times positive 2 is a positive 2x. Now we go to the next row. X times 5 is a positive x5. And positive 5 times positive 2 is a positive 10. And then the directions say to add diagonally. So if I were to diagonally do that, we kind of go like this. Okay, which would give me x squared plus 7x plus 10. So we just took, in an example like 2 slides ago, we took x plus 2 times x plus 5 and we distributed it. And then in this example, we took the same thing and we box methoded it. Okay, either way, both of them are going to work. Okay, as long as you remember how to add like terms, then this will make sense for you. Okay, so now I believe we're just on to a bunch of examples. Okay, so I will split them up. I'll do some with the box and I'll do some with distributing. This first one, I want to show you what that looks like in terms of distributing. So first, x times x, x squared. Outside, x times negative 4 is negative 4x. Inside, 3 times x is a positive 3x. And then last, 3 times negative 4 is negative 12. Okay, so combine like terms gives me x squared minus 1x minus 12. Okay, and this one we'll do a box. Both parentheses have 2, so I know I'm going to do a 2 by 2 box again. Okay, so 2x minus 3. 3x minus 5. Okay, so 3x times 2x, 6x squared. 3x times negative 3 is negative 9x. 2x times negative 5 is negative 10x. And negative 5 times negative 3 is a positive 15. So when we add diagonally, this is just a reminder too. Well, that's kind of cool. That's how we do our diagonals. Okay. There's only one x squared, so 6x squared. Negative 9 plus negative 10 is negative 19x. And that's a positive 15. Oh, hey. So, positive 15. There's my final answer. Okay. This one we'll do again with the FOIL method. So first, O-I-L. So first, so x times 6x is 6x squared first. Outside. Inside. Last. Okay, so first outside, inside, last. Okay, and when we combine like terms, 6x squared plus 26x plus 8. Oh, this looks like fun. Let's box it. So I know it's going to be a 2 by 2. First one goes on top, 2x minus y. Second one, x plus 2y. Okay, so 2x times x should be 2x squared. Negative x, or I'm sorry, y times, positive x times negative y is negative xy. 2x times 2y is 4. That should be a 4, sorry, 4xy. And 2y times negative y is negative 2y squared. Because remember, we have to add the exponents. So we diagonally add, okay? So 2x squared minus, or positive 3xy minus 2y squared. Oh, we can box this one. Okay, this is one of my favorite types of problems because everyone forgets how to do them. And I say that in the nicest way possible. And the reason people forget is because we have this little squared on the outside. Okay, and a lot of people, they take this number 2, this squared, and they just go, oh, we're just going to square everything inside and then we're good to go. Wrong. Okay, that little squared on the outside means we're taking this 2x plus 2 and we're multiplying it by itself 2 times. So really, we have this 4x plus 2, which is 4x plus 2 times 4x plus 2. That's what that means. Okay, so don't let that little squared there fool you, because that squared is just saying, we're going to multiply it by itself twice. Okay, I think the box method is going to be the easiest way to do this particular problem, because we're going to have numbers all over the place. So 4x plus 2, 4x plus 2. Okay, 4x times 4x, 16x squared. 4x times 2, 8x. Oh, I was about to put a squared. Nope. 4x times 2, 8x. 2 times 2, 4. Okay, so diagonals, we're going to add whatever's on those lines together. So 16x squared, plus 8x, 8 plus 8 is 16. Holy cow. 16x plus 4. Y'all, it's been a long day. Okay, there we go. 2 x's. Whoa, hey. Same idea with this one. Let's actually FOIL this. FOIL. Okay, so first, I'm going to rewrite this because I know that this is actually 2x minus 3y times 2x minus 3y. Okay, so the FOIL method tells me first, so we're going to multiply. That wasn't very nice. We're going to multiply the 2x's together. So 2x times 2x is 4x squared. Outside tells me 2x times negative 3y. Okay, so that's going to give me, we're going to multiply our coefficients together, so it's negative 6xy. Because I can't add those exponents together, so it's just going to be x times y, which is just xy. First, outside, inside, which is just going to be the same thing, negative 6xy, and then last, negative 3y times negative 3y, positive 9y squared. So when we combine like terms, 4x squared minus 12xy plus 9y squared. Okay, and this last, I'll lie to you, this last one's kind of my favorite, and we're going to box this one. Okay, and this one's going to be a little bit different because this last polynomial here has 3 terms. Okay, so when we do a box, we're going to do a row of 3 and a column of 2. Okay, so it's going to look a little something like this. Row of 3, column of 2. So we're going to put that 4x squared on the top, that x and the minus 5, and on the side we're going to have a 3x minus 2. Okay, so remember, before we go forward, this 3x has an exponent of 1. Okay, so when we multiply them together, same with this x up here, just remember we have to add our exponents together. Okay, so we have 3x times 4x squared, which is 12x cubed. 3x times x, which is 3x squared. And 3x times negative 5, negative 15x. Now we do our bottom row, negative 8x squared, negative 2x, positive 10. And we're still going to look at our diagonals, okay, and still add them together. Okay, so we only have 1x cubed, so we have a 12x cubed. Negative 8 plus 3, negative 8 plus 3 is a negative 5x squared. Negative 15 minus 2, negative 17x, and then a plus 10. Okay, I highly recommend that you print out these notes and you copy them down, and that you follow along as I am working these examples. Okay, write down any questions that you might have so I can answer them in class.